Good evening, everybody. Thank you so much for joining us this evening. I mean, what else would you rather be doing on a Monday evening than be here with us? For the new faces, I know there's quite a lot of new people that are joining us this evening that haven't joined any of our previous masterclasses. So my name's Jennifer, and myself and my husband, Ben, who's also on the call helping with the IT side, we're the co-founders of Project Self-Build. We completed our own self-build last year. We had various challenges, to be honest. It was quite a roller coaster. And we found the whole process actually was quite isolating in some respects. We didn't have anyone else around us that was completing a self-build. In fact, quite a few of our friends just thought we were nuts. And also there's a lot of information out there, and it's quite difficult sometimes to know who to listen to. And, who is the actual expert? And if you go onto YouTube, it's a minefield, to be honest. So we created Project Self-Build, and our mission is to create a trusted community where individuals can learn, share knowledge, and be inspired to hopefully build their own dream home. How we're going to do this, our plan for this year, is we're going to focus on hosting regular masterclasses with industry experts such as Mark, who's joining us this evening, and also he's waving there. And also we're looking to interview other self-builders that are either in the build process right now or have recently completed. So if you're out there and listening and fancy being interviewed as well, do let me know. We're going to be very much guided about what you as the community would like. So if there's specific topics you want to learn more about, or just let us know. We're here to try and help. I won't waffle on any longer, and I'm going to hand over to Mark. So yeah, thank you very much for joining us, Mark, and I'll let you do your intro.
Well, thanks for that introduction, Jennifer. Pleased to be here to see if I can help anybody with their project. I recently have assisted Jenny and Ben with their own project, and we've looked at a number of solutions for their house. And it's an area which I've worked in for quite a long time. And as time's worn on, renewable energy has become an increasingly important part of considerations if you're building your own house. I think self-builders were possibly the best early supporters of this type of technology. Many of my early customers, sort of 15, 16 years ago, were self-builders, and they were keen to secure their future, knowing that they were going to be in this was their dream home. They were going to be in it for a long time because that's all they'd ever wanted to create. It's a very important part of building your own house. So we're going to go through a few things in here, and I'll explain a bit about who I am, who we are as a company, the problems that homes face, and I may touch a little on existing properties as well. The importance of fabric first, a little bit about heat distribution, looking at sources of heat energy, generation and conclusion, and then I'll follow it with a Q&A session. So who are we? Well, I formed Your Future Energy because I felt there was a need in this marketplace to offer people independent advice. As I said, I come from a background of working as an installer, putting a lot of these technologies into people's homes and businesses for the best part of a decade and a half. And I felt that there was a lot of what I could only describe as snake oil probably in out there, and contradictory information and things which were just purely, and products being sold to people, when self-builders being one of them, that were not necessarily right. So I felt that there needed to be an independent voice out there to help advise people. And there's a number of us now, and we go out and visit people and we work through to conclusion on their projects with them. The main sort of problems out there, I think, at the moment are people's perceptions of what things can and can't do. A lot of people thinking, renewable energy is unsuitable for their property. A lot, and as shown by that search of YouTube videos I did, a lot of negativity and false information out there, and quite often when you trace it back to the source, you can find it's from one particular lobby or another. But there also has been quite classically quite a lot of installations that have been of various renewable technologies that have been done poorly, and these have led to sort of false interpretations of what a technology is or isn't capable of, because these modern technologies, say for heat pumps or solar or whatever, are only as good as the people who've put them in. And if you don't install things correctly, they won't work. They'll lead to high bills and all sorts of problems with the running of the home. And this then leads to the misconception that these things don't work, when actually they work perfectly well when done properly. So there's a lot of misinformation and false information on the internet, and that sort of needs to be really avoided. And as a self builder, you need to find trusted people to work for. Now, it might not be, say, someone like me, an independent advisor, although that is an option, but a good quality in technology installer is really what you want to be looking for. Being able to go and see jobs that other people have done, talk to others of their customers. A good installer should be able to introduce you to a number of their other customers and demonstrate through that they're capable of doing a good job for yourself, someone with a similar portfolio to the work that you're asking them to do. Much as some people would like to economize on the materials they put into the build, it really is a case of looking at fabric first. Your biggest use of energy in your home, unless of course you're building an actual passive house, and very few are, because it also requires a certain lifestyle, your biggest usage will be heating, either the form of what comes out through your radiators, but also hot water. And investment first into the fabric of the building before we even look at energy is the right way to go. You should be looking to develop with your architecture builder a box which doesn't leak, because it's absolutely key place to start. It's not a we'll just bolt on some technology afterwards and it will be fine. Everything needs to be looked at holistically, both the building materials, insulation being one of those, air tightness of the property, which is now a requirement under building regulations that's tested, and possibly heat recovery as well, so that rather than having ventilation holes around the property, say in the form of trickle ventilation, that you are actually using mechanical ventilation to recover some of the heat that would otherwise be lost to outside, like when you shower. The next bit, sort of following on from that, you should pay attention to how heat energy gets about your home. Put a picture down there of an engine, chassis, brakes, a few other bits and pieces, because certainly with renewable heat technology, the core need of any home, the system is only as good as the parts that are connected to it, in the way that a car engine will only perform well if all of the other pieces which it's connected to are equally as well designed and put together. There are a number of different ways of distributing heat around the house. There's a couple of pictures there which obviously are underfloor heating, which is a very popular and sensible choice for most places, particularly new builds. Radiators work adequately well, but they are the renewable heat, it tends to be quite sensitive to the design, so you've got to ensure that as part of this process that people don't just say, oh, there's a window which is this big, right, we'll put the radiator under that's about the same size, because that's where these things fall over. Everything has to be not only executed well but designed very accurately, otherwise it simply won't work. There's a number of different renewable sources of heat that you could think about employing in your self builds. Pictured here are a few different things for reasons, and I sort of work my way through it. Biomass pellets up there on the top right hand side, appropriate in some situations. However, they've more recently come away from offering subsidies because the actual embedded carbon in processing and transporting them, and some of the sources would be far from green. But personally, I can see the sense in using wood that's locally sourced and possibly from your own land, but it requires a great quantity to do it. There's been a lot of talk of hydrogen recently, in and out the press quite regularly, and conceptually it's a great idea, with the only byproduct really being water from the process for providing heat. However, it's got a fair set of problems in ever getting into the existing infrastructure. It's a highly reactive chemical, and it will react with metal piping. There's an acceptable level of leakage of gas within the gas network. There isn't really an acceptable leakage of hydrogen, unless you wanted the area to look somewhat post-apocalyptic. So I don't really think that's fully evolved yet. In fact, putting in a hydrogen-ready boiler at this stage, during its life cycle of say 10 to 15 years, it's unlikely it will ever receive anything other than a smattering of hydrogen down the pipelines in its entire lifetime. So that really leaves us with heat pump technology. And really, as self-builders, I think putting up houses right at this moment in time, you have to look at what is available. And there is, various technologies being developed, but currently the most reliable form of heating technology that will offer you the largest cost savings in terms of running costs would be an air or a ground source, or possibly, if you have water on your land, a water source heat pump. They use the refrigeration cycle, which is hundreds of years old, to extract heat from either the air, ground, or water, or whatever the medium may be, compress that heat, which is captured within a gas, and then that gas, when compressed, is warmer and usable for either warming your floor, your radiators, your hot water cylinder, or whatever. It's classically received not great press over the years because it's been installed like a boiler or just clipped onto an existing system. But if you're starting out with a good design of both the heat pump and the heat emitters and all of the linking pipe work, cylinder, what have you, and your plant room, then it can provide the lowest running cost heating of anything currently available, other than potentially sort of if you're burning your own forest, but then that wouldn't be very green. So whilst the heat is generally the core requirement for energy and should be dealt with first along with the fabric, we could also be looking to potentially supplement the energy with various things. Solar is on everybody's mind. It's a very easy thing to understand. We've had solar powered pocket calculators since I was a little boy, and it's fairly self-explanatory. You put it on the roof, the sun falls, it generates electricity. However, it's not currently possible with the kind of climate and levels of sunlight we have here to entirely rely on it, particularly if we were employing something like direct electric heating, which is incredibly energy intensive. Our requirements for heat energy are polar opposite ends of the year to that of when the sunlight is being produced. So yes, you'll have with the right levels of solar, with electrically based heat pump heating and hot water, a good portion of the year you can run on solar, but you can't entirely run conventionally off grid without a little bit of input energy. However, this can be where you can possibly bring in battery technology. The battery technology will allow you to ride out those bumps during the interim sort of spring October months, hopefully charging from spare energy left on the roof, but also during the winter when the solar really can't be relied upon. A battery will allow you to purchase energy on off-peak tariffs, things like the Tesla tariff, which is actually a flat rate, or Octopus Go would be a good example as well, although it's not open to new customers anymore. But there are a number of tariffs that are originally designed for electric car users to help effectively flatten the curve. You can buy the electricity at, say, for example, 1 to 5 in the morning and charge while you're sleeping, and then let the house use that throughout the day. And the right size of storage is whatever's appropriate, what you're trying to achieve. So it might be that you want to rely, for extended periods of maybe no grid connection, or you would like to supply everything from that battery for a number of days. And so you need a correspondingly large or number of batteries. There's a similar sort of thing with the solar panels as well. Yes, you've got a finite roof space if you're roof mounting it, But if you have land, you've also got the option there to ground mount it, and it can sometimes be as big as you want it to be. But it's usually a case of looking at what the core load of the house is, and then trying to find the right economic balance between the number of solar panels you have, the requirements of the house, and how much you actually want to rely on it. And you'll usually find that there's a perfect point there at which you're spending a sensible amount on generation, but you're not spending so much that you're sort of wiping out any gains you might otherwise have. So this should be thought about as part of the overall picture, but you shouldn't be spending money on things like batteries and generational technology until you've sorted out the core demands of those houses. So I would probably best describe that as the things like solar panels for the roof. While they're instantly visually can show that you are generating some energy yourself, shouldn't necessarily gazump in the budget good heat retentive properties of the building, or a renewable source of heat for that building. In conclusion, really, you've got a lot of things to think about as a self builder, and a lot of stretches and strains on the budget, which drive a lot of the decisions which you make. However, there are certain decisions which are easily changed later, and how the property works from an energy perspective requires that all the right pipes and wires are designed in from day one, and generally they'll be embedded in the walls, the floor, the roof, you name it, and very difficult to put right afterwards. It might be a desire for a nice spare bathroom, but actually if that's going to then trump doing the right thing from an energy perspective, then that might be better put on hold, because a bathroom is very easily removed and replaced, as opposed to cables up through a building, which might actually never be able to be put right without quite destructive and expensive work. So you want to set yourself up right from the go. And if you can't afford to do all of the things you'd like to do energy wise at the time of making the build, at least have some kind of mechanical plan for how you'd like the ultimate building to work and what you would like in it. Because if all the right cabling, pipe work, and things of that nature are in place, then it's just a case of when you get a bit more money in 2 years' time, you can go out and purchase that piece of technology and add it on with ease, as opposed to doing, either not doing it and then being stuck with a subpar house, or having to do quite destructive works to the house. So it needs to be a primary consideration, because your energy costs going forwards will be one of the biggest continual monthly outgoings for the duration of the time that you're in it, and doing something right at the beginning will pay back dividends in the future. So I've now sort of come to the end of what I wanted to say, because I wanted to cover things at this point in a kind of a global way. If you'd like to contact us later, you can scan the QR code, and that'll allow you to make contact with me and the team. I'm going to open it up for questions now, if people want to ask anything specific. Anyway, I'll hand back to Jen, who can field some of your questions.
Fantastic. Thank you so much for that, Mark. You shared some really useful information in that. And I can definitely say, from experience of having worked with Mark now, I very much wish that I'd had somebody on side that was an independent consultant to come and look at our build right at the design stage, because there's actually some things that we're working on now that are going to be retrospectively fitted effectively. We could have been, it would have been a lot better if we'd done that from the beginning. So I'm just going to run through some of the questions. You're welcome also, if you'd like to put your hand up, probably on the Zoom button for the hand up, because I can't see all of you, that would be great. And I'll also just read out some of the questions that we've got in the chat, if that's okay. Okay, so this is from Gary. He said, thanks for sharing. We have people telling us that the use of air source heat pumps can cost you roughly £5,000 per month in energy costs. That sounds crazy, and we're wondering why. That is crazy.
It is. Well, first of all, I'd quantify it and say I don't know how big your house is. You may own Buckingham Palace, in which case it might be £5,000 a month. However, if you own a more conventionally sized house, then if an air source heat pump is incorrectly installed, it could cost you an absolute fortune, because when they don't work properly, they work on their immersion backup heaters, which rack up huge costs. So it's absolutely key, buyer beware in that, and do your homework with the installers. Ask people who have had good installations, ask their clients about their running costs, because the industry is relatively infantile in the UK. In Germany and France, that simply isn't the case, and they have more checks and balances to prevent bad installations. However, our market is not as mature here. But if you had a conventional size house and you had a heating bill of anything like that, there's nothing wrong with the technology, but everything probably wrong with how it's been implemented.
Brilliant. Thank you, Mark. Dominic, he says, hi Mark, if I'm installing a ground source heat pump with underfloor heating with plenty of roof space, what is the priority? RE, PV, solar therma and PVT?
Right, okay, so should probably just clarify the 3 points. So he's telling me, I'm assuming he's telling me that he's going to do a ground source with underfloor heating to provide to do the heat and hot water for the thing, and that he's deciding what priorities between solar thermal panels, which just heat water, and conventional solar photovoltaic panels, which just do electricity, and a sort of a hybrid panel which you can get some heat back from the panel itself as well. Well, I think personally that, and you know, the jury may be out on people have different opinions, but I can only speak from my own standpoint, that I would say that using either PV or PVT panels would be the solution there. I don't think that solar thermal does enough in relation to its cost. So it's purely there to do the hot water, generally speaking, although it can be applied in other ways. And it only works when there's enough of a temperature differential on the roof. And this is often at polar opposite times to when it's needed. And I'll give an example of that in work to explain myself. So let's say, for argument's sake, that you get up at 6 in the morning, the family all has a shower for work by 7 o'clock. There's very little sun and temperature enough on the roof to transfer over onto the cylinder. And so the boiler, of whatever description it might be, it needs to kick in to top the heat in the cylinder back up. It will sense, because you've used up all the water in the showers, that the cylinder is needing heat. Nothing will be coming from the roof, so the boiler will then kick in and top it up. The sun will then become usable in temperature later in the day, but the cylinder's already at temperature, so it can't absorb an awful lot of temperature from the sun. And then the other time you're likely to use the solar thermal, use hot water, and therefore create a need for solar thermal is for potentially sort of bathing at night. And again, there'll be no solar there to top it up. So you have a choice of whether to just have no hot water then for periods of time and rely on it heating in the day. And also, it's the UK, so the sun's inconsistent. But solar and solar PVT panels can be used to generate electricity as well, which can be, then all of the energy can be captured that's available, as opposed to solar thermal, which will generally stagnate and potentially cost, the cost meaning that you'd end up with a sort of a 30-odd year payback, by which time it would need replacing anyway. So it would depend on what your goals were. But if your goals were to be as green as possible, you might include the solar thermal as well. But if it's purely financial, you might be looking at some of the other alternatives.
Brilliant. Thank you, Mark. I hope that answered the question there. I've got a question from Sally. She said, interesting food for thought. How do we calculate the load we need to then build a sensible case for where it is the break point of what we spend on solar PV batteries versus the gain we achieve for 60 to 70% of the year? Is there an easy cost versus benefit calculator online for this? That's a great question.
It is, and the answer is I don't know. If there was one, I'd be using it. But usually you need to analyse each house individually, and also discuss with the person how much what they'd like in terms of the storage. You know, in the place where you are, for example, Jennifer, you're in a fairly off the beaten track area, and you do experience power cuts. And so you've got more reason than a lot of people to have a fairly substantial amount of storage. So you need to take it on a case by case basis and work it out. But yeah, if there's a quick online calculator, I'll be happy to be directed to it, because it would make my life a lot easier.
Okay, thanks, Mark. Sally says, thank you. I suspected that might be the case. Maybe I'll develop one this time next year, Rodney.
Okay. Yeah, I'd fund that.
There you go, Sally. There's a business idea there.
Yeah.
Gary asked another question, and he said, what would be the average monthly cost for a 3-bedroom house? Was that relating to air source heat pumps? I think that was, Gary, wasn't it? Do come off mute if you want to add anything else to that question.
Yes, that's right.
Yeah, okay, great. So it's relating to the running cost of an air source heat pump for a 3-bed house.
Okay, so if it's a new build house, and we say that it's, you know, average 3-bed house size, so maybe what, like 130 square meters. I mean, we shouldn't be looking at sort of more than, if it's done right, more than £100 a month to heat it, really. It depends on the size of the house, the levels of insulation or whatever, but
is that heating
and how warm you keep the house as well. But it certainly shouldn't be anything like 5,000.
Is that for the heating and the hot water, Mark?
Yeah, yes. Yeah, the hot water is more expensive because when the heat pump is doing a hot water cycle, it's working at a much higher temperature. However, the hot water is only done intermittently, whereas the heating during the heating season is fairly constant. So it tends to be that the bills are, depending on the habitation, somewhere between 90-10 and 80-20 in favour of the heating.
Thank you. Gary says, great, thanks. Aidan's question, so looking at building an 85 square metre 1-bed house on the Isle of Skye, wow. Going to use an air source heat pump with PV and battery, is there a minimum coldest temperature that the air source heat pump is ineffective?
So they'll still be effective down to sort of -15, and some of them even down to -20. However, their efficiency suffers as it gets colder, and that very much generally depends on the quality of the unit that's installed. Some of the cheaper far eastern stuff takes a real dive when it starts getting cold in terms of performance, which is generally expressed as a coefficient, and that coefficient goes down and down as it gets colder. So it will still work, it will still provide heat. However, in the very coldest times, it will use more energy to do that because it has to do more work. The compressor is an electrical motor, and it's using its power to take you from temperature A to temperature B effectively. So it's a steeper slope from temperature A -10 to temperature B 50 degrees than it is, say, from temperature of +7 to 50 degrees. So the harder it has to, because it is an electrical motor, the harder it has to work, the more electricity it will consume. That said, the times of the year I mean, I can't say I know Skye how cold it is. I'd assume it's colder than down in Devon with you, Jen, but the times of the year where you are at very cold temperatures is often only a small portion. So generally, the fact that it is a bit more inefficient at those colder times isn't so much of a problem, because it's only for a small portion of the year that it's actually operating at those under those conditions. In somewhere which has got extreme temperatures, it may be worth considering a ground source heat pump if that's an option. If you think you're going to experience sustained periods of real cold, a sort of more Scandinavian or Canadian temperatures, then they ground source is definitely a consideration. But the heat pump will work. Air source heat pump will work under any UK conditions, short of a catastrophic big freeze that we don't never really see.
Brilliant. Thank you very much, Mark. Okay. Kate's question is, if there's plenty of roof space for solar with batteries, realistically, what percentage of your electricity use should your setup be able to provide? Appreciate depends on usage of family.
I would say that it would be a half decent setup will do most of the stuff between March and October. But then from the simple lack of sun, you will probably struggle. And that seems to be fairly proportional, because obviously a big house has a big roof, has bigger demands, smaller house, smaller roof. But, you know, I would also say that it does need to be facing the right way. And I think people's orientation of their properties is going to be increasingly like yours, Jen. It benefits from facing south. It gets the full force of the sun, and the solar panels can be orientated perfectly with the direction of the house. Whereas if you move off of that, you end up with suboptimal performance if you're keeping them on the house.
Yeah, it's a really good point, actually. We were very lucky with our barn conversion that it was south-facing, to be honest. But it's definitely something to consider with any new builds. We've got a couple of hands up. Jonathan, have you still got your question?
Yeah, so it was going back to the Isle of Skye one. Mark, is it worth mentioning that obviously the Isle of Skye is a high humidity environment, so an air source is going to have to go into its defrost mode a bit more than you would eventually find elsewhere. Yeah. So it's just something to be aware of more than anything.
Yeah, it's I'm aware of it being cold, and it will, of course, probably operate. But that said, you know, they are used in Scandinavian countries with some regularity, and yes, it will operate more inefficiently. It will do more defrosts. It will have to use higher compression. It will use more electricity.
Brilliant, thank you. Thanks for that, Jonathan. Mike's question is, please explain the water heating cycle as opposed to a fabric heating cycle on an air source heat pump. Are you happy to come off mute, Mike, just to elaborate a little bit more? It's Mike Neal.
Yeah, hi. I think I understand the sort of refrigeration cycle quite clearly, but I wasn't aware that that heat pumps had. You're suggesting a different mode for heating hot water, so presumably that would be a higher output temperature and corresponding reduction in the COP.
Yeah, that's right. Yeah, so they will be sensing what they have to do, and generally most setups are set up as hot water priority, because you figure the hot water is more of an immediate need to have readily available hot water. So it'll be taking constant readings around the system, flow and return temperatures, and it will also be looking at the temperature of the hot water tank, sometimes in multiple places depending on the design of the system. So when it finds a need, because the sensor is telling it to create hot water, because let's say the temperatures drop from 60 down to 40 because you use some and some cold water has been introduced into the tank, it will then go into hot water mode, where it will look to run to its set hot water temperature, which can be, you know, some of the decent air sources can be up to 70 degrees now without the need for an immersion heater. And it will switch over a three-way valve from B back to port A. It will, which can be best described as coming up to a T-junction and having to go right or left. And then instead of going right and going through the heating system, it will turn left and go round a coil inside the cylinder, which acts like a kettle element, which then heats the water, and it will run and run and run until it achieves its target temperature within the hot water cylinder, and then switch back to heating mode again. Does that answer That's what you needed to
Yeah,
know?
I wasn't aware that it's operates at different temperatures for different parts of the cycle.
Yeah, it can also operate at different temperatures for different zones as well. If there is a problem zone for heating, or you have a mixture of underfloor heating and radiators, which isn't ideal, but if that's what the economics of the build dictated, you could potentially have one temperature going to radiators, one temperature going to underfloor, and one temperature going to the hot water cylinder, and various permutations of. So it can be as complex or as simple as you need it to be. Whereas a boiler would just generally produce one temperature that it's sent out down the pipes to everything. This is probably maybe where your question came from.
It was just trying to understand how the system works and what the bottlenecks are likely to be in terms of design. And I mean, my sort of immediate thing from that would be that it would sound sensible to oversize the hot water cylinder.
I think in that regard, well, firstly, you need to make sure it's an appropriately designed hot water cylinder, because you're working with different temperatures to the boiler.
I do understand that.
Yeah,
yes.
Yeah. So and nobody ever really complains a great deal about having too much hot water. It's generally too little. Most of the modern cylinders, if you get a good one, have got very little in the way of standing losses. So you should. There is defined quantities of hot water that you design in to meet British standards, but I would tend to want to have a little in reserve, so that I knew if I had people over to stay that I didn't run out and have everybody queuing for the shower.
Brilliant. Thank you, Mark. I hope that helped, Mike.
Yes, thanks.
The next question, sorry, I'm trying to get through them all. I know there's a few people waiting and I can see a hand up as well, so please bear with me. A question from David. We're converting a church in Yorkshire, so have the envelope, but we're looking at the best way to heat the underfloor heating water. We want to use air source heat pumps, but we'd need 2 or 1 and a gas boiler. Is one approach better than the other?
Yes, if it's possible. Yeah, so the need for 2 air source heat pumps may also mean, depending on the size design, without knowing a lot of the other criteria, you must check that you've got sufficient electrical power at the site. So that means some cases that people have to run in either an additional single phase or 3-phase electricity if they've only got 1 single phase already, so that they can sufficiently cover the extra load from 2. Now, I think particularly if you're doing all of that work to convert a church, and you're hopefully going to be in there for a long and happy time, that maintaining the fossil fuel element, which is, the target that is clearly being intended to be got rid of at certain levels in the country, that keeping that fossil fuel element means that you're not moving on from its reliance, because the system will rely on a good portion of the year, and for the hot water generally, on the gas boiler. So I would argue that there's very few circumstances where it would be necessarily to do that. It's a bit like a hybrid car in a way. There's perfectly serviceable with reasonable range electric cars, and so for most circumstances the fully electric option would be the best, but that's not necessarily always the case. I'd need to know a little bit more about the circumstances. So how much, if you did need extra electricity, how much was that going to cost to bring it in? Is there a gas connection already? How much is that going to cost? And then sort of weigh it all up. But I generally would err away at this juncture in time from building non-renewable elements into buildings when it wasn't absolutely necessary.
Brilliant. Thanks, Mark. I'm not sure of the name, but Sound Solution, whoever's called that on here, I know that you had your hand up and you're being really patient.
Yeah, she's had it up for a long time, actually.
Yeah, I'm sorry.
I just put it down because I was a bit embarrassed with it sticking up there still.
Oh, no, sorry. I was trying to go in order, but yeah, please do ask your question.
Absolutely fine. I'm Catherine, by the way. Hi.
Hi,
Catherine.
Catherine.
So we are very new to this. We're in the process of buying a plot. So this will be a really poorly phrased question. I hope you can make some sense of it. We went to see somebody self-build a while back, and in their house they had a heat source pump, underfloor heating, solar panels, and they also had something which I think was called a thermostor, which was like a water cylinder that held excess power from the solar and could be used rather than wasting excess energy. Do you know anything about that? Does that sound like something?
It sounds like an amalgamation of things.
Okay.
So the thermal store is normally something that's put in to be able to accept heat from lots of different sources. So maybe if you were combining a boiler with a back boiler, and you then create this heated thermal store of water, which you then pipe out to the radiators, and potentially have a coil going through it for hot water. But those things are rely on very high temperatures. They're not done very often. What it might be is that they had a controller that's a brand name would be Solar iBoost, which allowed them to divert excess electricity from the solar through the iBoost, which would work like a variable resistor and just let through what was excess rather than fully turn the immersion on, and then that would then be stored as heat in the hot water cylinder.
Okay.
which could then be used. So that's earlier when we were talking about whether we'd use solar thermal PV or PVT panels in order of priority. That's the beauty of the electricity, is even if there isn't enough sun to make sensible heat, anything left over can still be driven into the hot water cylinder, and it's a relatively inexpensive thing to do. The add-on to a solar PV system to be able to control a immersion heater and just put any spare energy into the hot water tank is a piece of equipment that costs about £400. Okay. So it's a relatively easy thing to do. Now, I'm not quite sure whether that's sort of what you were. Was that what you were meaning?
It was the idea that if there was excess, you had a way of storing it that attracted me.
Yeah.
And as she described it, so what it looked like was a kind of boiler shaped thing, but it wasn't a boiler. It was a place where the energy was stored. She described it as like a battery. And as you speak, I wonder if it was because she had a back burner as her secondary source.
Well, that's
the logic of it.
Yeah, that sounds possible. Although linking a back burner and a heat pump can be fraught with a few problems.
Yeah, I can't speak.
That's probably for another talk.
You've explained very well the notion of the battery use as opposed to that sort of store use, so that's helpful. Thank you.
Yeah. So you're battering the heat up within a cylinder, and by diverting the energy from other places, and then that heat is then saved within that cylinder until it's used.
Okay, thank you. Thank you also for the session. It's brilliant being here. Thank
you. No worries.
Thank you, Catherine. Okay, I'm going to keep going through the questions. There's another one from David, which is there a benefit of installing a 3-phase power supply for your air pump efficiency? Not really.
There is arguments for installing 3-phase for future-proofing your house. So lots of compressors, which as we mentioned earlier, are the core parts of an air source heat pump, actually start life as 3-phase pieces of electrical equipment, and they often have a number of ways of starting added to them that reduces their initial current drawdown. One of them is a soft start, others use capacitors, and having a 3-phase heat pump actually means that there's generally less wear on it than it's single. There's less componentry to it than the single phase models, because it doesn't have to have this thing to allow the current to be ramped up, and it can just go straight in. But as regards to efficiencies, it's not really going to be one or t'other. But I would think about 3-phase if you're future-proofing your house, because there is potentially a need for people to be able to rapidly charge their cars, to be able to live an electric car lifestyle. And as we move to more and more electric cars, that's going to be increasingly problematic if you don't have sufficient power. So to fast charge a car, you need 3-phase power. There's no way that I'm aware of to fast charge a car without it, because there simply isn't enough ampage carried by a 100 amp supply, especially when you consider that it has by a single phase charger. So if you wanted to use your car, if you were sort of in and out and charge and go, and you might want to consider 3-phase for that reason, as well as also being able to, you know, as we can increasingly adopt more and more electrical things, being able to have spare energy coming down the line to support them. But efficiencies, no, not really, not anything significant.
Okay, thanks, Mark. I think we've probably got time for 2 more questions, so I've got them lined up. Sue's question is, we're about to have approximately 12 kilowatts of solar PV plus 3 times 5.8 kilowatt batteries. We're on 3-phase 2. Is it worth having a solar diverter to immersion heater too? And also, which is best, a heat store or a conventional hot water cylinder? We will be a large 2-family house, new build, almost to passive house standards. Quite a long question, sorry, Mark.
Okay, I'm just having a think about that. Well, anything spare that you don't use in the house will go back to the grid, and you'll pay far more to draw it back from the grid, and then the grid will give you. So the only thing left for giving back to the grid is about 5p a kilowatt hour under the smart export guarantee. However, you'll be paying sort of 35-40 to draw it back out, generally speaking. So it doesn't hurt to divert some of that spare energy. It should, with all of that, you should, with all of that PV, you probably will have a significant amount of spare energy. It would really be a case, the installer should probably present to you a document or documents that show the coverage of your own self-usage, and if there is enough spare energy that some could be diverted elsewhere, then yeah, I don't see why not. It's a relatively inexpensive part of what's a fairly substantial install, so I don't think it could hurt. And was there a second part to the question as well, Jen?
Yeah, it said, and also, which is best, a heat store or a conventional hot water cylinder?
I think possibly I answered that with the previous question. So if all you're doing is making hot water and all you're using is a heat pump to do it, then a conventional heat pump hot water cylinder would be absolutely fine, unless you were docking other things into it.
Okay, thanks, Mark. And the final question is from Philip. I'm planning on a vertical ground source heat pump, but you mentioned water source. I have a large well. Is this something I should look at also for heat conversion?
Yeah, I mean, if you have, so if you're doing a water source, you've got a number of different ways of doing it. First way you can do it is you've got a lake in your garden or a river, which you can exchange the heat with, either by sucking it in and blowing it back out again, or having a direct heat exchanger within the body of water, of which I've actually done both. And the good news, if you have got water available, is a water source heat pump done correctly is generally one of the most efficient systems that you can possibly have, because it's all about start to end temperature. So if you've got water at 12 degrees and you've got to shift it up to 35 for under or heating, well, heck, the heat pump doesn't have to work very hard at all. But it's worth caveating it with a number of things. First off, it's an incredibly large amount of water in most houses. So it may require an abstraction license if you're taking it in and out the water table. Secondly, the well probably won't be designed to hold that kind of volume of water, and you actually have to squirt it back out somewhere else, otherwise you'll just freeze the water that's in the well. So it would require a second hole digging as a minimum. And thirdly, if you're taking in and out of a well, you may find that you're clogging the pump all the time and the system's breaking down. So it'd probably be better if you have got very high groundwater, and so it doesn't take too much energy to pump it out and round, as it were. Then it may be sensible to get it drilled, get both wells drilled properly, the suction and the return well, so that you can create a hole that's not going to have potential contamination that a older well possibly would have. But if you've got to have it, and again, depth, you'd probably want to have a look. If it's a very deep well, it may take a lot of energy to pump the water back up, and if that's going constantly while the heat pump's going, it needs to be added into the total electrical consumption of the heat pump. And if you've say got a 1.5 kilowatt pump going all the time, because you've got to lift it up at 80 meters before it gets to the heat pump, then that's like running an immersion constantly at the same time as using the heat pump. So it really starts to affect the efficiency. So it'd be worth taking a deeper dive into the exact detail of that. But yeah, it potentially has got some use, although it may be more indicative of where the water levels are and that there is a lot of water available, as opposed to being actually usable itself.
Great, thank you for Mark. Thanks, Mark, for that. Apologies that we're not going to be able to answer everybody's questions. This is one of these topics where I know it's very easy that we probably could go on for another 45 minutes to an hour. So I'm going to call a cut off at 8 o'clock, but I just want to thank Mark so much for his time this evening. I know it can be a bit intimidating as well in front of everybody. He's got so much useful knowledge to share. It's really appreciated. And thank you everybody as well for turning up this evening and answering those questions. I'm sure a lot of them are useful for everybody to hear. If you'd like to contact Mark and you've got any other questions, or have a chat to him about what he does as well, because from my own research, there's not very many independent renewable energy consultants. I specifically wanted to find someone that wasn't affiliated with any, for example, of the solar panel manufacturers. Then do scan the QR code and you can get in touch with him through there, or drop him a message online. But yeah, thank you very much for this evening, Mark.
Thanks, Jennifer. Pleased to help.
Brilliant. Thank you very much, everybody, and hope you enjoy the rest of your evening.